Okay, hi, Fred B here with an update on how my repair of the Johnson Millennium 250H head is going. The head that was connected to a dead short on the output. And here's the output board again. Now in my earlier video, I touched one of these, and I think it was this one. I noticed that it was loose. One of these direct outs actually didn't work for me when I had the amp running before. I thought it was some kind of configuration error, but when I got this board out, it became evident that the solder joints on the other side here had broken free. Let's see, that would be here's one here. These solder joints had actually broken free. I noticed a number of little soldering errors on the board of this particular board. The wave soldering, I'm not quite sure why. Most of them involved when I replaced the battery holder on the main board too, that some of the solder just did not stick to the PC board all that well in some spots. Mostly all it worked okay, but there was a number of little spots where it didn't stick well. Not quite sure why that happened. But now, these two, and I even went and resoldered the one that was secure in there to settle those. Now, going back here, you can see now I have, let's take my screwdriver again, put it under here. I have removed the two transistors, these two transistors, from the circuit board, and it was quite easy. I just used my desoldering tool, and then they just lift right out of the holes like that. This heat spreader bar is screwed fastened to the PC board, so I just left that in there. And I got these two out, and I'm not sure if I can show you here whether how good our zoom is. It's going to focus. And I guess it won't quite focus. But you can see the cases on these, to get a little pointer. The cases on these cracked, kind of diagonally on both. There's a little crack. Yeah, it runs from this lead kind of in towards the center. Both of them I found were cracked. Maybe you can see better on this one. Crack runs right about there, right along that line. Now, I'm supposing none of the other transistors are cracked, so I'm supposing that these were the plastic case is cracked because of overheating due to the over dissipation from connecting the output to the dead short. Now, these transistors also were attached to silicone rubber pads. The light's shining on that. They just peel right off and stick. The engineer at Harman said I can just use these old ones over again. So buy some more transistors. These are $1.80 TO218 case. Bipolar transistors, and we'll put them in the board, and that reinstall the board back in the chassis of the amplifier, and that should complete the repair. Why eBay think that I would send an amplifier out in condition that I can easily repair it really just drives me out of my mind, and I'd very much enjoy chewing eBay's head off for this, but you know, I'm a private individual and eBay is a massive corporation, so just you know, guess who loses on that one. Okay, well, I will continue the update when I get some more transistors, whenever I can afford to buy them. And there is one thing I wanted to add, and that's a comment about the design of this amplifier. Overall, the design I think is excellent, but this amplifier has an output section of bipolar transistors, two bipolar transistors. It's a push-pull, and you have two bipolar transistors on each half of the push-pull and two channels. Now, the designer of this amplifier went so far to include an inductive dampener. So we have a little coil here of a few microhenries plus a resistor in parallel with it. That constitutes a part of a Zobel network. I'm not quite sure if there's a capacitor in here. There's a 47 UF capacitor here too, and another that's an electrolytic, and one that is non-polarized. I'm not sure. I'd have to look at the schematics to see if there's a capacitor in here to form a Zobel network. But they went so far as to add this inductor on the output of the amplifier to dampen transient spikes. And my point is, if they went that far to design this, they created this whole output section for this one channel without any protection for overcurrent conditions. If they had protection for overcurrent conditions, this repair would not be happening. And I just happen to have been studying the design of solid-state audio output sections, power amplifiers, both with the bipolar and MOSFET drivers, and everywhere I read on all the forums I've been covering is whenever somebody sees an output section for like a DIY home stereo amplifier, they say, hey, that'll work, but you neglected to put in overcurrent protection. And, first time somebody shorts the output, you'll be sorry. And, well, I'm kind of wondering why, John Johnson, who's obviously a very competent designer, would fail to put output protection circuitry on the solid-state output section of his amplifier. It's a fairly high-powered amplifier. Each of these channels is 125 watts output. And some dingbat like the guy I sold this amplifier to will hook up one channel to a dead short, and pff, there it goes. So, remember, this is a lesson for me. To remember in my designs to always include the overcurrent protection on the output of the circuit. It's a little additional work to simulate that circuit and design its provisions into the board. But this is a very good lesson as to the benefit of having such a circuit. Okay, thanks for watching.